In this video, we're going to talk about assessing normality. So up to this point, we've been told in many of our problems that a random variable x is normally distributed, or at least approximately normal, provided the histogram of the sample data is symmetric and bell-shaped. This works well for large data sets, but the shape of a histogram drawn from a small sample of observations does not always accurately represent the shape of the population. So in this section, we will discuss additional methods for assessing the normality of the random variable x when we are looking at a small set of sample data. So the very first example deals with the data set of hitting 75 golf balls with a pitching wedge and the distance in feet. Now, notice in this particular example, there is a large amount of data values, greater than or equal to 30. So the histogram is a good indication to show if the data is symmetric or not. Less chance for outliers to affect the data set. Okay, so let's take a look at a small data set. So a random sample of college students was obtained and the number of hours of television watched in a typical week was recorded. Since there is a small data set, less than 30 data values, the histogram is not as good of an indicator to determine if the distribution is symmetric. Outliers could really affect the histogram because there's not as many data values. If the data set has a small amount of data values, we should use a normal probability plot to determine if the data set is normal or not. So a normal probability plot is a graph that assesses the normality of a data set. So to create a normal probability plot, we would take the z-score of each data value. This is represented by the vertical axes. The actual data value is represented by the horizontal axis. These are the ordered pairs used to graph on the normal probability plot. So, if the sample data is taken from a population that is normally distributed, a normal probability plot will be approximately linear because we know with a z-score that that's going to be the data value minus the mean divided by the standard deviation, but we can separate it as 1 divided by the standard deviation times x minus the mean over the standard deviation. Well, that's just a linear equation in the form of y equals mx plus b. So, if sample data is taken from a population that is normally distributed, a normal probability plot will be approximately linear. So, we will not do these by hand. I will show you how to put these in the calculator. I may ask you to sketch the probability plot using the calculator, but I will not have you do this completely by hand. All right, so let's take a look at an example. So I want to create a normal probability plot for the previous example. Do you think the data could have come from a normal distribution? Well, let's go to the calculator and see how we can put this in. Okay, so you can see I put the data values in for L1. So once you put the data values in, hit second and y equals. We'll go to plot 1 and it's turned on. Go to the type. For me, it'll be on the far right side. Highlight that picture, hit enter. Okay. The data set for me is going to be L1, so I'm going to hit second 1. Data axis is X. The mark is fine. We'll do blue. So once all of that is done, what do? Hit the zoom button and then hit 9, zoom stat. Okay. And there's your normal probability plot. Yeah, that looks approximately linear. Looks like a line. So here's what we're going to write now. So yes, the data could have come from a normal distribution since the normal probability plot is linear. Okay, one more example we'll take a look at. A placement exam is given to entering freshmen at a large university. A simple random sample of 20 exam scores is drawn with the following results. Do you think this data came from a population that is normally distributed? Justify your position. Okay, so let's go back to the calculator, put these data values in to help us create our normal probability plot. Okay, so I put the data values in again for L1. So let's go through this process again. So we hit second, y equals. I will go to plot 1. Again, make sure it's on. I'm going to go to the far picture. If you have 2 rows of 3, it'll be on the bottom right. Hit enter. Again, the data list is still x1. X for the data axis is fine. The mark is fine. So once that is all set up, then hit zoom, and then number 9 for zoom stat. There's your new normal probability plot. Now, this time around, this looks more like a cubic function rather than a line. In other words, it looks like something of y equal to x cubed. So the normal probability plot is not a line. So let's write up what that means in the context of this problem. So the data didn't come from a population that is normally distributed, since the graph of the normal probability plot is not linear.